So today's problem is problem number 14 of the MIT 2024 integration B regular season, which is the indefinite integral of e to the power x plus 3x. This is definitely an interesting problem. Before I try to solve it, I'd like to thank our subscribers. Thank you so much for your support. We don't take it for granted. It's a support that brings us here time and again. For first-time visitors, what we do at Everyday Mathematics is we go about and around and look for interesting problems, and we come back and do share the solutions with you. I also like to thank our repeating visitors. If you haven't subscribed, please do consider subscribing to the channel. Your support would really, really mean a lot to us. Um, so I can try to rearrange this problem a little bit. And how to do that is using the rules of exponents. When you do have addition in the powers, it means that, and having the same base, it means that that's the same as the multiplication of the base to the power of 1 and the same base to the power of this, the other part that is being added. So here, e to the power x plus 3x is the same as e to the power x times e to the power 3x. And then e to the power 3x is the same as e to the power x to the power 3. We could distribute e to the power 3x a little bit in a different way. So it's the same as e to the power x to the power 2 times e to the power x. And if we let u to be equal to e to the power x, that means that du dx is the same as e to the power x. And so you could substitute e to the power x times dx with du. And so for our problem here, it means that this part here is u, this part here is u, and this part here is du, right? And that's what we've done here. So same as e to the power u, u squared du. And then obviously derivative of e to the power u is the same as e to the power u. So this e to the power is the same as derivative of e to the power u with respect to u. And so using integration by parts, where if you have capital U dv, that's the same as uv capital U capital V minus the integral of capital V du. Right? And so here, because we could take v to be e to the power u and u to the power and u to be u squared. So uv is the same as u squared times e to the power u minus the derivative du is 2u. So constant 2 comes out, and then we have u to the power u times e to the power u. And then we can repeat the same process here, e to the power u being dv. I mean, the derivative of u being the derivative of e to the power u being equal to dv. So v is the same as the power u, and u being equal to u. So uv being equal to u to the power times e to the power u minus, it's here, derivative of v, which is going to e to the power u, times derivative of u, which is just 1. And so eventually we can now combine this up. So we have u squared times e to the power u minus 2u e to the power u minus minus becomes plus. The integral of e to the power u is the same as e to the power u plus the integration constant c. And so if we have that expression, since u is equal to the power x, where u appears, we can plug in e to the power x. So our original integral of e to the power x plus 3x is the same as e to the power x squared times e to the power x because of this u minus 2 times the power x times e to the power x plus 2 times e to the power x plus the integration constant. Can rearrange things a little bit. This e to the power x squared is the same as e to the power 2x times e to the power x minus 2 the power x times e to the power e to the power x plus 2 times e to the power e to the power x. Pulling e to the power e to the power x out, so we have e to the power 2x minus 2, e to the power x plus c, all multiplied by e to the power e to the power x plus the integration constant is what we get. And that's the final answer. So yeah, thank you so much for following along. I hope you did enjoy solving this. There are probably other ways of solving this, uh, like using logs. But other than that, I think this is an interesting problem. And so till next time, I'll Tutalu, Halat Question for.